Hello everyone. In today's video, we're going to talk about Physics 253, Week 4, problem number 24.24. In this problem, we are asked to find the minimum surface charge density that will produce a spark atop a needle, given that the electric strength will exceed a certain value in newtons per coulomb. So starting off this problem, we want to make sure we note our given value here in newtons per coulomb for the electric field strength, and we can go ahead and draw a little image here. Wasn't quite sure what to draw for this one, but here we have an electric field radiating outward from a needle, and here we have our spark right here. So starting off this problem, it's important to read chapter 24.6 in the book, specifically discussing this kind of usage of Gauss's law in charges. I've gone ahead and noted some of the equations that I'm using here and here. So starting off, we're given in the book this equation here, which we have our electromagnetic flux and our surface, our area times our surface. This is important because we're going to need to use both our epsilon naught somewhere in the equation. We're going to need our electric field strength at the surface, and we're going to need our charge density here. So what we can do is we can rearrange this equation. Since we're not given any value for area, we can go ahead and cancel our area here. If we set this here equal to this here, what we could do is we can just go ahead and cancel our a values and just solve for this right here, which is also a given equation, which is our electric field strength equals our surface charge density divided by our permittivity of free space. And then we can just go ahead and rearrange to solve for our surface charge density. So if we go ahead and define some of our constants that we're going to be working with, we have our permittivity of free space epsilon naught as 8.85 times 10 to the negative 12 farads per meter, and we have our electric field strength at the surface as 3.0 times 10 to the 6 newtons per coulomb, but we can also rewrite this as volts per meter because there's a one-to-one difference between the two, so there's no need for any conversion. But if we rewrite like this, then our units in the end will be a lot easier to work with. So as you can see, I've gone ahead and rewritten our units, and we are just plugging straight in for our surface charge density here, and then we're left with this value. At this point, our answer is in farad volts per meter squared, but we can say that this should be 1 farad volt here, but 1 farad volt equals 1 coulomb, so we can just go ahead and rewrite this answer to say that our surface charge density is going to be 2.7 times 10 to the negative 5th coulombs per meter squared. We are just rounding up here for our sig fig, and yeah, I'd say the most important thing to keep in mind for problems like this is just kind of when to I guess we want to think about what problems or what units we have available and what we're given in the problem, so we can go ahead and rearrange Gauss's law depending on our area of our surface or kind of what constants were given in the problem. So yeah, I hope you guys found this video helpful, and thank you very much for watching. Have a great week.